All right, so I've done a lot of work on restoring my Codaphone 700. I've changed out a bunch of caps, completely recapped it. There's no caps in it that are still original. It has just been redone altogether. I've added a DC bias pot adjustment. A DC bias tape adjustment, so I can adjust the DC bias on the tape. That was off, so I was able to trim that out properly. I've done a lot of stuff to this. You can kind of see the WIMA caps, the red ones sticking out there. So this is quite a bit better than normal. For doing the calibration work, which I'm going to go over in the videos, I've hooked up some good coax connections directly to where they need to go, so that I can do that all properly. I have a carefully selected, this is exactly 600 at 0.00 ohms termination that I have to use during the calibration procedure. What I'm also going to do is I'm going to cover frequency response and some other stuff. I'm going to be using a bunch of really cool equipment, and I'll go over that in the next video. Well, I guess we just continue right here. So, all right, let me put this down. And so what I'm going to be covering here is what you're looking at is a Tektronix frequency generator. That's up here. And this is a frequency counter, so I'm producing 1 kilohertz right now, or pretty close to 1 kilohertz. This is the voltage output that's going to be going to it. This will be 40 millivolts, as we'll see once I get it hooked up and we're ready to calibrate. This will show my waveform, also shows the frequency up here too. This also has, millivolts per division up on it. This will all be more important when we get to playback. So this is showing the signal that I'm going to be giving the answering machine. It's a spectrum analyzer. That's the 1 kilohertz sine wave with some harmonics and some noise. But this is 10 dB per division vertically. So this is 10, 20, 30, 40, 50, 60. That's almost 70 dB of signal to noise on that signal that I'm going to be using for calibration. That'll be important later once we look at how the performance off the outgoing message tape actually performs. Anyway, so I'm going to go ahead and do setup, and I'll do another video. All right, so I'm all set up to do calibration and measurements on the Codaphone 700. I've let that warm up, and I've got it all in the right mode and set up, ready to go. And I've got the test equipment warmed up and set up and ready to go. So what I'm going to do is, let me put this down. 1 kilohertz approximately, 40 millivolts. This will drop when I start to record. So what we want is about 40 millivolts. Obviously nice clean waveform going in, and the spectrum's pretty clean, a little bit of noise here and there, but overall good to go. Oh, and this is 10 dB per division, so this is 10, 20, 30, 40, 50, 60, 70, a little over 70 dB signal to noise ratio. So that's what I'm going to record. So here we go. So now what I do is I press this and I start to record. There'll be a pop, and then there'll be a brief second, and then you'll see the level drop as we begin to actually do recording. So here we go. So we're now actually recording the test tone. We're going to record some number of seconds. What we want is 40 millivolts going into it. That is approximately what we have. We have 1 kilohertz. So I'm going to let this go for quite a bit of time. because I do want to record a bunch on here so I can look at the spectrum of my output. You can see now that I'm recording that this is cleaned up. You can see that's a very, very clean signal going into it. And that's at 40.3 millivolts. At pretty close to 1 kilohertz. That's the frequency up here. So I'm just going to let it record fully until it runs out of incoming message tape. Or, I'm sorry, outgoing message tape. Also note that the level is very stable too going into it. It's not going to look this way when we play it back. But the signals I've got going into it are obviously very clean. Yes, it's a long outgoing message tape. It's like 3 minutes, a little over 3 minutes. Not that I would ever record one that long. But this does give us a lot of time to study the signal on playback. In this mode, I've got the microphone out, so that's part of the calibration procedure is to remove that. Oh, seems like that tape is forever. There we go. Okay, so now I've recorded it. I'm going to stop the video and then I'm going to do a video for playback. Alright, so we're now doing playback. Ideally, the level should be about, well, the manual says 50 to 60, 0.5 to 0.6, but 55 is obviously what I'm trying for. You can hear the wow and flutter. That's when the waveform is kind of changing speed because of the flywheel and stuff. We're generating a plot now for spectrum. And that's, not so good. So it's 10 dB per division this way, so the noise is about there. It says 10, 20, 30. That's like 40 dB, which is better than its spec. It's supposed to be 35 dB. So not bad, but it's close. A little bit better than the specification. But generally, there it is, calibrated. I'll move it up a little bit, tiny bit in level. It's a tiny bit low, but overall, there we go. And that's pretty much what I would expect. 0.5. The spectrum plot is what it is. And overall, not too terrible for an answering machine. So there we have it. What I'll do is I'm going to do some frequency measurements next. So I wanted to get the 500 hertz spectrum because it doesn't do so well at lower frequencies. You can see nonlinearities and you can see all the harmonic content. That's the primary, and these are the harmonics of it. It's just really quite nasty looking. but it is what it is. It's 500 hertz, and so the next thing I'll do is I'm going to do a frequency response check, and I'm going to get my 3 dB down and my 6 dB down points. Okay, so for this test what we're going to do is it's going to be a little different. We're going to measure the dB and we're going to sweep it. We don't need a spectrum analyzer for that, so that's off. Ignore displays over here. What to watch, this is the frequency that we're going to be measuring, and that's going to be the dB. So I'm going to go ahead and start it, and then once we have the 0 signal, then I'm going to go ahead and 0 it so we can see where our points are. So now I come over here and I wait for it, and I 0 that. That's at 1 kilohertz is our 0 point. So we're going to go down in frequency first. So that's 900, 800, 700, 600, 500, 400, 300, 200. Now we're going to go back to 1 kilohertz, and then we're going to go up. So back to our 0 point. And now we're going to go up. It's 1100, 1200, 1300, 1400, 1500, 1600, 17, 18, 19, 2K, 2100, 2200, 2300, 24, 25, 26, 27, 28, 29, and 3000. 3100, 32, 33, 34, and 35. So overall, not too bad. It's doing better than specifications for the frequency response. I particularly was focused on the low end because the low end was particularly terrible looking, and at least it's a lot better now and holding together. We barely got down to 400 before, so now we're getting down all the way to 200, so that's a good improvement. It also makes for less distortion in the mid-band, the 500, 600 range, which is where voice is, so that's important. Anyway, so there we have it.